Good morning friends. Today I am going to discuss about the circular motion when an object is moving in a circular path. The object is known as to be in circular motion. Suppose there is an object which is moving in a circular path, moving with velocity, constant velocity v, and every time the direction of the velocity, but we see that every time the direction of velocity changes at each point. Suppose when we are at here at this point, the velocity is in north direction, and at this point it is in west, here is in south, and here is in east direction. So velocity is every time changing from p, q, r, s, from point p to q to r to s. Even if the velocity is changing in this direction is different from the previous direction or the coming direction. So in a circle we have infinite time the direction of velocity changes. So here we can say that direction of velocity changes, that means velocity is keep on changing here of circular motion changes. That means when an object is in circular motion, velocity keep on changing. Whenever there is a change in velocity, acceleration term comes in an account. That means whenever an object is in circular motion, there will be an acceleration term will always be there. So next few term which we have to discuss about this in the circular motion, that is the angular displacement. First, angular displacement. Angular displacement is denoted by the symbol theta, and its unit can either be in degree or radian. Radian is its SI unit. So what is angular displacement? Is change in angle of a body, change in angular position of a body when it's moved in a circular path. So this is the theta. And this theta is an axial vector, and it's a vector quantity. Its direction is denoted by using the right hand thumb rule. According to this rule, what happened? The curl of the finger, the curl of the right hand give the motion of the object, while the thumb give the direction of angular displacement. So what happened when an object is moving in this direction? Suppose an object is moving in anti-clockwise direction in a circular motion, the thumb will indicate the direction of the theta because it's an axial vector. In this particular case, the object is moving in anti-clockwise direction, so theta is denoted by dot. This dot and circular symbol is the symbol for outward direction. That means object is direction of the this theta is outward. The next is that when we are considering it to be clockwise, that means object is not moving in this direction but in clockwise direction, then the direction of the angular displacement will be inward. We can use our right hand again, and we can see that the curl of the finger is denoting the direction of an object in circular path, and this thumb is indicating inward. That means it will be indicating the path of an angular displacement. Okay, it's clear. We are having the next term is angular velocity. Angular velocity is denoted as omega, which is the rate of change of angular displacement with respect to time. Suppose an object is moving with angular velocity omega. When this definition is defining for the average angular velocity. That means from some time from 0 to time t, how much the angular velocity has been covered by an object in time t. Okay, so next is the instantaneous velocity, which is denoted by omega instantaneous. It's come when delta t approaches to 0. That means change in the time is nearly approach to 0, and by using the mathematics, limit approaches for delta t approaches to 0, this term is changing into derivative of angular displacement upon time. This is the instantaneous velocity, instantaneous angular velocity. That it's mean that whenever it defined the angular velocity at every instant of time. Suppose we have to calculate the velocity, angular velocity at time t is equal to 2 seconds, and we are having some formula. So at that particular time we will find the angular we use this formula of instantaneous velocity at that particular time t is equal to 2 seconds. When we talk about the average, that means we are using certain range. Suppose from 0 to 2 seconds you have to find the velocity. That means from 0 to 2 seconds, that means you are using the velocity at 0 second, at time t is equal to 0 second, and at time t is equal to 2 seconds, and then we are taking the difference, and after that divided by the change in time. So this is the difference between the average velocity and instantaneous velocity. Okay, so we are having a relation between the angular as well as linear velocity. Linear velocity is denoted by v, and the relation between v and r is come from the v is equal to r omega. If it's moved with velocity v and circular path with of radius r and moving with velocity omega, this is the relation for v equal to r omega. This relation is valid only in circular motion. How we are noting it in vector form? V vector, velocity vector, is equal to r cross omega. This relation is valid in this relation is always valid, not even in circular motion but in all the motions. And similarly we have a relation between the angular as well as linear displacement, which is denoted by s. Suppose a distance covered from here, from point linear displacement covered from point P to P prime is s, moving with velocity v and making an angle theta. Theta is the angle between from point P to P prime with this. So what we will use arc method, sector formula, in which the angle theta is equal to arc upon radius. So theta here, arc is linear displacement s and r is radius is equal to r. So s is equal to r theta. This is the relation between linear displacement upon the angular displacement. Here is the linear velocity upon the angular velocity. Okay. So here the next term which come is the acceleration part. Whenever there is a we have seen that in a circular motion there is a change in a velocity. So change in a velocity leads into acceleration. There are two kinds of linear acceleration in case of circular motion. So what are these two? First one is centripetal acceleration. which is denoted by AC. Next is tangential acceleration, denoted by AT. So what centripetal acceleration is? It's give the change, it's give us the change in direction of velocity. So centripetal acceleration give the change in direction of velocity, while the tangential acceleration come when there is a change in magnitude of velocity. So that means in case of when an object is moving with velocity v, there is a centripetal acceleration will always come into an account with a constant velocity. When there is a constant velocity, object is moving with constant velocity, centripetal acceleration will always be there. So centripetal acceleration, what centripetal acceleration is, it's always in the directed toward the center of the circle. Centripetal acceleration is always, it's directed toward the center along the radius. It's directed toward the center along the radius. So this is an centripetal acceleration. So if we are finding it from this point, centripetal acceleration will be this direction. From this point, it's from this point, or for any other point, it's always toward the center along the radius, and it is equivalent to the v square by r. Sorry, if we are having radius r, small r, so v square by r, and from the previous relation v is equal to, we know that r omega, so we can replace both the term over here, r square by omega square by r. So we are having omega square r is equal to the centripetal acceleration, and it's always directed toward the center along the axis. Next is the tangential acceleration. Was tangential acceleration is always toward the tangential part when there is also change in the magnitude also. Suppose at this point we are having a velocity v, then at this point v prime, at this point v double prime, then we are having velocity v triple prime. That means velocity is keep on changing, the magnitude of the velocity is keep on changing. At that point we are having the tangential acceleration. That means the velocity tangential acceleration is come into an account when there is change in the magnitude of the velocity. So tangential acceleration, we are having the formula derivative rate of change of magnitude of velocity. This is given by rate of change of magnitude of velocity with respect to time. That is the tangential acceleration. So in case when the velocity is keep on changing with respect to time in circular motion, we are having the net acceleration. We have the net acceleration. So the net acceleration will be in the net direction of the centripetal acceleration as well as the tangential acceleration, which is given by a net, which is given by the vector form a t square plus a c square. Okay. So if I make it separately, if I make the angle separately, that means suppose centripetal acceleration is in this direction, tangential is in this direction, so net will be in this direction, net acceleration is in this direction. So the magnitude of net acceleration will be calculated using the vector law of addition. Suppose net acceleration is making in alpha with tangential direction, with tangential acceleration. So we can find, in that case we can find the angle of net acceleration, which is equal to tan alpha is equal to AC by AT. So this is the way to find the net acceleration. Okay. So the next topic will be the centrifugal and the centripetal force. Centripetal force. So what leads into the centripetal acceleration is the centripetal force. Centripetal force is given by the mass into centripetal acceleration, and we know that centripetal acceleration is equal to mv square by r. So centripetal force is equal to mv square by r, or it's also equivalent to m omega square r. This is equal to centripetal force, and it's always directed in the, like its centripetal acceleration, it's always directed into the center. Okay, this is the centripetal force. So what we have to know about that, the centripetal force is there is nothing extra new kind of a force come into an account. Centripetal force is all the rest for is a net force. What the centripetal force is? The net force acting towards center. So centripetal force is nothing but there is not any kind of a new force, it's actually the net force acting toward the center. Suppose an object moving in, what happen in case of electron and nucleus in an atom? We are having a nucleus over here and an electron moving, revolving around this path. So there is a electrostatic force come into and play. So in this case centripetal force will nothing but equal to the electrostatic force. Okay, when the earth revolve around the sun, then there is a gravitational force. There is a gravitational force acting between these two, sun and the earth. Here the centripetal force is nothing but equal to the gravitational force. Okay, so centripetal force is nothing and it's not any special new kind of a force, it's a net force acting toward the center. Next term which we have to know about the centrifugal force. So we have to think about it, that net force acting toward the center is centripetal force. What centrifugal force is? Next is we have to know about the centrifugal force. What centrifugal force is? Basically this is a pseudo force. This force is not actually occur. It's a feeling. It's a feeling, or when we will feel it, at what time this centrifugal force come into an account? When you are in a non-inertial frame. Non-inertial frames are those frames which are moving, which are not having acceleration equal to 0. Non-inertial frame, that means frame is moving in certain having certain acceleration. So what happen when an object is moving in a circular motion? Suppose we are having an object here. So observer who is observing the whole incidence over here is itself goes and sit on the accelerated frame, and which is keep on changing with, suppose at here it's point v prime, v double prime, and so on. So at this point what happen? A centrifugal force will act in the outward direction from the center, and we know that the centripetal force is acting in the inward direction if the circle is making an angle r with the radius r. So centrifugal force is the force which this person is feeling when it is sitting in a non-inertial frame and in outward direction from the center, and it's nothing but equivalent to the centripetal force which is acting toward the center. Is it clear? Okay, and it's not a force. Basically what happen when we are on a ride, when we are on a ride in a circular ride, what happen when we are on that ride, we always feel a centrifugal, we always feel a force which is acting outward direction, which is always acting in the outward direction. This is the feeling of the person which is itself in the non-inertial frame. Suppose an observer is observing the whole incidence from the outside, from the outside part. Suppose here it is standing, the person is standing over here and it's standing and seeing the whole incident. According to this person, there is a centripetal force acting toward the center, but the person sitting within the non-inertial frame, there is an outward force acting in the outward direction from the center. So this is the difference between centripetal and centrifugal force. This is a pseudo force, this is a real force. So next topic is turning. Next topic is turning of a car on a curve. So what happen in a case of a car when it's turned in a on a curve? Suppose there is a turn, okay, and this surface is this curve is making an angle R with the center O. An object is present having a mass m, and this is the rough surface. That means whenever there is a rough surface, friction come into an account. That means friction is always try to oppose the motion, relative motion of the object. When this object is here, there is normal force acting in the upward direction and downward force mg is acting in the downward direction, and the centripetal force is acting outward direction, which is equal to mv square by r. Since the surface is rough, there will be friction. So there will be friction acting in the toward the center, which is denoted by F. Okay. So by using the vertical direction equivalency, that means n is equal to mg here, because there is no movement in the direction because there is no movement in the vertical direction, so n is equal to mg. And here in the next case, when frictional force should be to this car, if we don't want this car to skid outward, this centrifugal force is to be balanced. Centrifugal force is to be balanced by frictional force. If we do not want this object to skid outward, the centrifugal force should balance by the frictional force. So the frictional force should be greater than or equal to centrifugal force in a limiting case, and F friction is given by the coefficient of friction into normal reaction, into normal force. So we can write F is equal to mu n should be greater than equal to mv square by r, and where n is equal to, from this equation we are having n is equal to mg should be greater than equal to mv square by r, and when r and r get cancelled, we are having v should be less than or equal to mu g by r. So this is the relation of turning of a car on a curve on a rough surface. Okay, when we are having suppose the surface is not rough, it's a smooth surface, then in horizontal case there will be more chances of the car to get skid outward, because there will be no any balancing force which is going to balance this centrifugal force at the turning point. Okay. So the next topic is banking of road. What happened in a banking of road? There is a leveling up of the road at the curve point. That means at curve position there will be a leveling up of a road. That means it will be at the outer edge, the level of the road. Suppose this is the road, it will be up in that direction, so that there will be, to avoid the accident and all the cases. Suppose the object is making an angle theta, the level of banking will be done at angle theta, and object is on a which surface? Suppose in first case we are having frictionless surface. There can be two cases, either friction case with friction and banking without friction. So first case we are considering where the banking is without friction. So from the center we are making an angle normal. So this object is in contact with the surface, so the normal will act in the perpendicular direction, and in downward direction we are having an mg, and this is making an angle, and a centrifugal force will act in this direction, which is equal to mv square by r. Okay, so normal is making an angle, this angle is also equivalent to theta. How we'll calculate this angle to be equal to theta? This is 90 minus theta, and this angle is also equivalent to, with that we are having this angle is also equivalent to 90 minus theta, and from this theta 90 minus theta, this is equal to 90 minus theta. So the whole overall this angle is equal to theta, and this is in vertical direction we are having the n cos theta, and in the we are having horizontal direction we are having the n sin theta. From the balancing equation we are having n cos theta is equal to mg, n sin theta is equal to mv square by r. Okay, so dividing the equation 2 with 1, so we are having the sin theta upon cos theta is equal to mv square by r upon में mg. mg will get cancelled with mg. Tan theta is equal to v square by r g. So this is the relation for banking of road in case of frictionless, in frictionless case. So this is the angle with which the road is banked up. Okay, and this is the frictionless case. Next case is the friction one case, when there is a friction. So we are having, in a frictionless case we are having tan theta is equal to v square by gr, when there is no friction. When there is no friction, v is equal to under root में gr tan theta. Okay, there can be two kind of cases when there is a turn. Either there is an increase in velocity, either there is velocity more than gr sin theta or less than under root में tan theta. So what happen in these two cases? When the velocity is greater than under root में gr theta, what happen? When velocity is more, car will skid outward. So when velocity is more, car will skid outward. So what happen? What will the friction do? Friction force, what the friction force is, it always opposes the relative motion. It's always in the opposite direction of the relative motion. So the car will skid in the outward direction when velocity is more. Sorry. So the friction, what the friction? Friction will be in the sorry. Friction will be in the inward direction. So friction in this case will be here in this direction. In the inward direction. This is angle theta and this is making an f cos theta, on here we are having the f sin theta. So in this case what happened, this is the ideal case, the equation will get changed and cos theta is equal to f sin theta plus mg when we take the vertical part. When we take the horizontal part, f cos theta plus n sin theta is equal to mv square by r. Okay, so by solving this equation we will get, and in case of friction we will put the maximum value is equal to the mu n. So n cos theta minus में mu n sin theta is equal to mg, and n sin theta plus mu n cos theta is equal to mv square by r. By solving these two equations, what we will get? We will get sin theta plus mu cos theta upon में cos theta minus में mu sin theta is equal to v square by r g. That means v is equal to under root में g r sin theta plus mu cos theta minus में mu sin theta. So these are the term in case when velocity is greater than gr tan theta. When we are having velocity less than gr theta, then what happen? Car will skid inward. If car will skid inward, the friction will be outward. So here in this case, what happened? Friction will act in the outward direction. Because car is skidding in inward direction, velocity is less, so it's making an angle, suppose angle theta. So here we are having a f cos theta, here we are having the f sin theta. So the equation get changed and we will get n cos theta plus f sin theta equal to mg. Then we are having n sin theta minus में f cos theta equal to mv square by r. When we will solve it, we will get sin theta minus में mu cos theta upon में cos theta plus mu sin theta bracket में gr. So when velocity is greater so this is the formula when we have velocity greater, and this is the formula when velocity is less than. So this is the formula when velocity is greater, and this is the formula when velocity is less than the under root में gr tan theta. Thank you. Here is the end of the topic.